Thank you all for joining and allowing me to present today about why lake houses are becoming a de facto for organizations building their scalable data architectures for anywhere from business intelligence to AI initiatives. I am Vini Jaiswal, developer advocate at Databricks, where I helped advance AI and data use cases at many companies of various sizes and verticals globally on Apache Spark, Delta Lake, and other related open source technologies. I also helped scale a company from lower hundreds to now we are 5,000 plus employees. Previously, I worked as a VP of data science at Citi and a data analyst at Southwest Airlines. And I love to travel and connect with companies and people all around the world. So if you happen to ever meet me, I would love to get to know you. Thank you. So with my background and experience, I'm standing here to provide you valuable insights and best practices that I have learned over the years working with the customers for building and implementing lake houses and provide a comprehensive understanding of what is this modern architecture, why lake houses, right? Databricks is the inventor and pioneer of data lake house. Gartner recognized Databricks as the leader in both database management systems and data science and machine learning platforms. Additionally, at Databricks, we created some of the most successful open source data projects like Delta Lake, Apache Spark, and MLflow, which are the foundation for Lakehouse architecture. So I have seen how firsthand how companies are adopting, why we built this architecture, and how we address the complexity of managing multiple systems and to improve collaboration. So let me go through the session real quick so that understanding is clear. Data architecture, as you may know, is a very critical topic for data engineers and professionals because it plays a vital role in the ability to manage and analyze large amounts of data and make decisions on based on data, right? So they are very critical to any organization's success. During this talk, we will cover the evolution of modern data architecture and how it has led to the development of lakehouse architecture. We will discuss the foundation principles of lakehouses, including, the concepts of data lakes and data warehousing, as well as I will also introduce some of the key benefits that lakehouse architecture offers. And also we will go into some production examples of how organizations have implemented this architecture to solve their data challenges. So before I dive into lakehouses, first let me walk through, how evolution has happened in data architectures and how we got to where we are today. So I'll start with data warehouses, which started back in like 1980s. Some analysts had this fever dream of making all your information available online and you can actually create insights. Data warehouses actually offered reliable data management and excellent performance for BI and reporting. However, because the format is closed, only the proprietary engines were able to read the data. And it was very suboptimal for machine learning frameworks because they did not provide support for data like audio, video, log files, text, the data sets that are very critical to modern use cases. And moreover, so it was expensive to scale out. So it was hard to do any machine learning and AI with data warehouses. This is what led to the data lakes, which is open, offers scalability and flexibility, and it can handle all the data types for data science and machine learning. This system was evolved very soon. It was popular and everybody started using it. But what soon happened is they realized that the data sitting in data lakes have low quality data because it did not offer some of the data management capabilities that the data warehouses offered. You need a transactionality, you need schema enforcement so that data is reliable. And as a result of that, the data turns into unreliable data swarms in data lakes, where you have all the data structured and unstructured, but it is very difficult to make any sense of it or maybe rely on it. And this is a maturity curve which actually shows companies that are leading the way in data and AI. They are using data in very strategic ways that has changed the landscape. the left-hand side of the curve actually is looking backwards, where you have the historical data and now you are trying to find out what actually happened. You are trying to understand the trends, right? So the innovators are over on the right side today. They are using the data to actually predict the future, to make prescriptive analytics and real-time decisions. However, the majority of companies are struggling to get their advanced data and AI efforts into production at scale. And one of the reasons is that most companies are actually using two separate systems for different purposes. They are using data warehouses so that they can do all the business intelligence and reporting. And they're using data lakes for AI applications. But these platforms are incompatible with each other. You generally need data from both the systems to deliver really game-changing outcomes. This makes it extremely difficult for companies to actually succeed with AI. So let's take a look at why this happens. Today, most of the data is landing in data lake, as I showed you before, and a lot of it is unstructured. In fact, about 90 to 95% of the data in any organization is unstructured, because they are now collecting various data streams. They are now collecting all the data they can. And this data is where a lot of value from AI is sitting. Then subsets of the data are being copied over to the data warehouse into structured tables, and in some cases back again into data lakes. Now you have to secure and govern data in both the places. Warehouses offer really fine-grained security, whereas lakes offer more coarse-grained at the file level. And then you stand up different stacks of tools on these platforms to do either business intelligence or artificial intelligence. This operating model creates three problems. First, you have duplicated data because now you have two systems, right? So changes that you make in one system are very unlikely to find their way to other, right? So you're going to have all your data drift almost immediately, not to mention you are paying to store data in multiple systems, right? And moving all the structured tables and unstructured files into the same data lake and leverage the cheap storage is more of a reasonable approach. And then, because governance is happening at two different levels across these platforms, you are not really able to control things consistently. So setting up governance and security in one place with access controls for files, blobs, and tables is very critical. Finally, the tool stacks on top of these platforms are fundamentally different, which makes it pretty difficult to get any kind of collaboration going between the teams that support them. You need a platform that can be one-stop shop for all of these use cases. Really, realizing that this requires two disparate, incompatible platforms, there is a tremendous amount of complexity and rework being introduced into the system. Time and resources are being wasted trying to get the right data to the right people, and everything is happening too slowly to get in front of competitors. So the ideal data and AI platform would operate differently. So these were the challenges that we have had before the evolution of modern systems, right? So whenever we go into like best practices and understanding why we should use and change with the architecture, how it is changing, you have to think about these challenges and then apply the best practices. So the solution to have one single system that can house data for many different workloads. This is why we have lake houses today, which is actually best of the both worlds. It's a portmanteau of data lakes and data warehouses. So let's take a look at the architecture. This is how a lakehouse architecture looks like. It's basically starts with low cost and directly accessible cloud data lakes. So you already have your data lake set up, right? All you need to do is use that and put some transactionality on top. So let's look at how. So now you have all your data structured and unstructured in one place in the form of data lake. You would have one platform that can accommodate all data types. And ideally, this platform is open too, so that you are not logged into any walled gardens. So how it brings reliability is it brings reliability and quality on top of data lakes without actually leaving the lake, with an open data storage format called Delta Lake, which is a Linux Foundation project. What it does is it offers asset transaction guarantees and schema enforcement. So now you're able to overcome a lot of challenges that data lakes have historically presented. And moreover, these formats that were built to solve data reliability problems exist because these were built on open source projects like Spark, Flink, etc. The projects that actually allowed you to handle massive data workloads to be processed very fast at scale. You would also have one security and governance model, and it would not only handle all data types, but it would also be cloud agnostic to govern data wherever it is stored. Finally, all of this comes together and you have dramatically simplified your data architecture and unlocked whole world of mission critical machine learning, streaming, and AI use cases. So this is the approach that we have invested in at Databricks, and I actually see a lot of customers deliver value on their data and AI application aspirations because of Lakehouse. So hopefully you are still with me so far. So that was about evolution of data architectures and how Lakehouses came into play. Now let me walk you through how you can actually build a data engineering pipeline using Lakehouse. So your data can arrive from multiple sources. It can be either a batch or in a streaming fashion. Now your data lands in a cloud storage such as Amazon S3, Azure Data Lake, or Google Cloud Storage. And then you add a structured open format called Delta Lake, which allows you to have a reliable data management and data governance capabilities on top of a data lake. Now you then prepare that data to fit into a design pattern, which is called the medallion architecture. And what medallion architecture does is it logically organizes your data in a lake house with the goal of incrementally and progressively improving the structure and quality of data. So now you have your lineage and separation of which layer where your data flows based on your use cases and downstream users, and it's called bronze, silver, and gold tables. So bronze is where we land all our data in from external sources as is, along with any additional metadata columns. And the focus of this layer is quick change data capture and the ability to provide your historical archive of source, for example, cold storage, data lineage, and auditability. Next, in the silver layer of the data lakehouse, the data from bronze layer is matched, merged, confirmed, and cleansed just enough so that the silver layer can provide you an enterprise view of its business entities, concepts, and transactions. For example, this can be master customers, stores, non-duplicated transaction, and cross-reference tables. So having this type of pattern, actually think of it if you are trying to solve a GDPR use case. Wouldn't it be nice if your data was already encrypted, or you already had managed the data in different formats, so that whenever you had to act upon like solving a inquiry that came in as a result of GDPR, you can actually able to locate record in just one single place, delete all the referenceable keys to the private information, and delete that actual data from your bronze table itself. Or maybe you have put it in the silver table because now you have two separate views. So that's how you think about when you are thinking about medallion architecture. And now the last one is the gold layer. So data in the gold layer of the lakehouse is typically organized in consumption ready project specific databases. It is for reporting and use cases which are more denormalized and read optimized. And this is meant for less sophisticated user. For example, you are doing customer analytics, you are doing product quality analytics, you are doing inventory analytics, customer segmentation, product recommendation, and so on. Those are the use cases that can fit into this category. So, this is the final layer of data transformation, and data quality rules are applied here. This is actually the final layer that can be multiple tables depending on how much data your organization deals with. So now you can see that the data is curated as it moves through different layers of a lake house. And this is what, you know, what is the best practice that we have seen, seen or deployed with the customers to build ETL pipelines. So you can ingest all the data, prepare it through the medallion architecture, and serve your downstream applications and use cases. And actually, more organizations than ever are adopting Lakehouse architecture to achieve their data goals. We are seeing enterprises like NASDAQ, Condé Nast, McDonald's, Shell, Ford standing up lakehouses. And these are the organizations actually which processes massive amounts of data. Just in Delta Lake alone, over an exabyte of data gets processed per day. And now it has like a community of 200 plus contributors. So these organizations have already realized how much value Lakehouse offers, and they are already accelerating innovation at their own on their own customer side. So that's the scale that we have worked with, and we have worked with almost half of the Fortune 500 companies. And also, like, there are some companies who run a cloud on the edge. They are digital natives like Samsara, Grammarly, and Instacart, who are revolutionizing their own industry. Because Samsara, for example, they are revolutionizing IoT industry by providing insights on their connected apps. They are preventing harsh driving conditions. They are preventing distracted driving behaviors. For example, during COVID, they actually were able to reduce the food wastage and deliver vaccines in time. So these are very like cutting edge use cases that they are able to do because their data is now reliable and it's sitting in a single system. And one more example I would like to take is for Amgen. Lakehouse enables faster data processing at massive scale for Amgen. It's actually unlocking a lot of possibilities of machine learning to enable innovations like speeding up the development of a groundbreaking treatment, cancer treatment. Or they are predicting, because whenever they actually find a cure, they want to make sure that how patients are responding to different therapies. So they are using Lakehouse architecture to make those predictions. And this is just a sample set of thousands of companies in every industry. The work that is being done is transformational for these organizations. And it is all because Lakehouse offers one platform that unifies their data and AI workloads, and it delivers a promise that data warehouses did years ago, but at much larger scale and flexibility. So by bringing the benefits of reliability and data management directly on data lakes, with lakehouses, you are now able to use data for decision making. And there are three key principles I want you to take away from it. Is it has to be open, it has to be simple for users, and it should support multiple clouds, because now your data is stored into multiple systems. So with that, I would like to thank you. And if you do want to get involved with any of these projects, we do have a huge Databricks community, as well as we have open source communities. So if you are interested in Delta Lake, we have delta.io projects, and we regularly, share some of the best practices. So please stay tuned with us if you would like to learn more. So I'm happy to take any questions here. Popular question actually, so let me address that here. The book, so we were releasing the product features very faster, and that was our main goal, to have our features released. So if you saw the announcement last year during our Data AI Summit, we announced that all of Delta Lake is open source, and that's what kept us busy. If we had the book already rolled out, it would be like staled at that point. So the book will come, I assure you that. It just has been delayed. So I do get that question, so I hopefully that helps. And then, is observability a typographical error or a new term? See, how I would like to address this question is, when you think of observability, right, when data teams were actually solving all these challenges, I think one of the principles I talked about was reliability, right? And one of the things that you can do to make sure that data is reliable, the decisions that you are making is reliable, is have some kind of observability for your system. So end to end, if you have a view of architecture, for example, right now we are working on Delta Life tables, which gives data engineers flexibility to view their declarative pipelines in a observable format. So you can see how your data is moving from different layers, and it also allows you to specify some kind of warnings or errors. For example, if my data, I can put a condition in my code, for example, data which is arriving from dates which are more than which are more older than 2021, just ignore that data because that would not be useful for my prediction, for example. So you can specify those kind of qualifying filters in your data lineage, and you are now able to actually observe those warnings, whether you have matched the conditions and remove those data from your pipelines. And another thing is, you also need to have auditability. For example, if there is an auditor or if there is an inquiry from government, for example, right? Now you want to make sure that you have a track record of when was the data changed, what are the data type, who worked on that data, how many rows were changed. You want to have that auditability. So that's why you should be able to see that in the statistics that is available with Delta Lake, for example. So good question, David. And then there's a question on, can you comment on advantage of Databricks over Snowflake? Look, these are both very great companies. They have solved their niche in very amazing manner. How I would like to differentiate them is Snowflake gives you amazing data warehousing capabilities, whereas Databricks is actually end-to-end solution. So if you are dealing with for example, I showed, right, data warehouses, they are not able to do machine learning and AI. They are not able to handle unstructured data types, the data sets that are very critical for modern business applications. That's where Databricks really shines, because you are now able to do data analytics or BI business reporting with the Databricks SQL. You are able to do data engineering and make sure that data is reliable and has schema management capabilities with Delta Lake. And now you are able to also do ML ops with Databricks. So these are end-to-end advantages that Databricks offers. Can you please, there is another question from Jagrati. She says, can you please relate gold, silver, and bronze zones with data lake and data warehouses? So I would say it's not exactly relatable, but let me give you an example in this format, right? So think of data lakes. It's like, you are literally putting in all of your data, garbage in, garbage out. I would, yeah, like for example, you have MP4 formats, you have video, text, audio files. You are putting that in the data lakes as is, so that can serve as a gold, sorry, that can serve as a bronze layer. But then when you apply transformations, that can also be in like a transformed table view, for example. So you have like some transformations applied, so which can be a mix of like data warehousing or data lakes. And finally, data, when I said gold tables, you have quality checks, you have the final transformations done on your final stages. So think of data warehouses where you have materialized views, and materialized views are actually used for your product analytics, or those are the views you create for very specific use cases, very specific teams who you don't want to give access to the raw level tables. So that's how I would relate to gold, silver, bronze with data lakes and data warehouses. And then, is there a use case for this in healthcare? Definitely. I think I showed you an example of Amgen, but there are a lot of companies who are using lake houses to, find a treatment or cure for cancer, to find, opioid use, for example, things like that. So the use cases that we are working on are massive. If you do want to learn more, I can actually send you a link in the chat where you can learn about different customer stories. Copy of the book, observability. I think I already addressed the observability, and data lineage is where you can actually see the flow of information, which I think I addressed by giving data live table example, where you can actually uh, have a clear picture of how your data is flowing, where your data errors are happening, things like that. So those are the main differences. Observability is basically like, if you have monitoring enabled in your infrastructure. Datadog is a very good example where you can actually see how much of the compute resource are being utilized, what query runs how much how much faster, so things like that. Okay. I think there is a question on, from what I can understand, that in designing Delta Lake has access to the underlying warehouse and data lakes. Is that correct? So I would like to separate these concepts. For example, if you have if you have stored your data in any systems, you can actually think of it as like a advanced Parquet format. So Delta, underneath Delta, it uses open source Parquet format. What it does is whenever you run that command to convert to Delta, it adds a transaction layer. So in your folder, you will have all your data, plus you will have a folder which says underscore Delta underscore log files. So that's very critical. So it doesn't matter if you have a data warehouse or data lakes, we have connectors to go to both of those systems, and you will be able to use Delta Lake on top of either a data warehouse or data lakes. So think of a Delta Lake adding a transaction layer. So now you have all the statistics, all the monitoring metrics, for example, for auditability. I think some of the questions were relevant to the slide. So does Databricks have any metadata? Does Databricks have any metadata management capabilities? If so, what capabilities exist? I would like to plug in Unity Catalog, which we are actively working on. I think you should be able to see that through this year or something. So that's an innovation we are bringing, and that's the trend I will see for the next 1 or 2 years, people using Unity Catalog.
Yep, so there's one question. Which is the more organized form, a data lake or a data warehouse?
Okay, so I think I will start by saying it also depends on your use case. For example, I would start by saying, like, more organized is data warehouse. But then if you think about, unstructured data, for example, right? Data warehouse are compatible with SQL formats, and they have like support for structured data. So I would like to think of it as like, uh, you know, data warehouses supporting a lot of organized formats. And sometimes what used to happen is, back in the days when there was any missing data, or if there was any data which didn't match the schema of your tables and data warehouses, it would avoid those data. But those kind of data actually gives you a lot of valuable information, and it should not be missed out. And that's why the data lakes were formed. Now, if you put transaction layer on top of data lake, that data becomes organized, right? Because if you add Delta Lake, for example, that's a format, you will actually see there is a very organized directory of files and directory of statistics for that data. So now you are adding that kind of organization to your data lakes as well. So it's about how you think about, designing your data architecture. It can offer organization, can offer, can be offered from both data warehouses and if you have a reliable data lake.